Okay, I just realized that my mic was my mic level was too high, so I'm sorry. You must have been going with lower volume. Hopefully, I just reduced the volume so that you guys do not. I mean, comes l- less troublesome. I hope that this works. Okay, so part of what an operating system does is actually creating and controlling the processes, as we said. Now we're going to look at the actual API that Linux slash Unix systems use to create a process, a new process, like the create process in Windows. This is the Linux equivalent. So we start by the concept of fork. Fork basically is a program that takes if you fork a program, you're basically cloning the program. You're running an exact clone of the program. And that clone, the cloned version of the program is a child now, is the child process. While the parent, the cloned parent, is the parent process. So Linux has a very weird way of implementing a new process. It does not actually implement a new process. It just replicates, clones the old parent to a new child, which is like, so in a sense, Linux started cloning way before cloning was a thing, right? Uh, and in doing that, Linux basically, and slash all Unix systems almost, they would copy, for example, the PCB. They will just change the name of the child. They will change things such as the heap, where it stars, the stack, the memory allocation, and so on. And but it will be the exact same program running. And this is what fork does. So this is a program that shows you how fork functions. This is a C program that shows you how fork functions. So you have the main, and basically you have printf, which prints hello world and prints the PID of the process, the current process that is running, that just started. And then you start fork. Okay. And fork returns a number. When you call the system call fork, it returns a number. If that number is less than 0, that means that there has been an error when trying to fork the parent. Okay? If the fork result is equal to 0, this means that this is now the child. If the fork program is not equal to 0 and not less than 0, i.e. greater than 0, then this is the parent. Okay, what does this mean? This basically is a very interesting way for thinking about process creation. When you Linux actually starts the new child and makes it run in parallel right away with its parent. Okay, so and it starts basically from the line fork was called. So it's like as if you are setting by using fork, you're setting two different RCs here. An RC value for the parent and an RC value for the child. So if you think of it, it's like you're going sequentially top bottom, and then you find the fork call. So now that since you have the fork call, you clone from here. You basically split into two, okay? And a parent and a child. And each parent, since I just said that that the parent and the child will be cloned versions, they will be identical. Each of them will have its own RC. And it will be just like as if you're actually allocating two different RCs, because now they are two different processes. And the fork system call will return 0 for the child and will return a number that is greater than 0 for the parent, and both of them will run in parallel. So if you run this program, this is the kind of output you'll get. So you run p1, which is like process 1, and you find, hello, I'm parent of 29147, and you find, hello, I'm child of 29147. So what happened here is that these two print statements in the if else part, if RC is equal to 0, there's the hello I'm child, and you put the PID, okay, and there is hello I'm parent of, and you put the PID, okay. And here's an interesting thing. So hello I'm I'm parent of was actually able to get the PID from the child. So I'm parent of and then you put the PID of your child. Okay, and so you see that this is 29147, while the actual parent PID was 29146.